Okay, so this lesson is called the properties of logarithms. There are 3 properties, and you guys, they're reversible. So we might, one problem, we might work from where it was multiplication, we changed it to addition. Then the next problem, we might have an addition problem, we have to change it to a multiplication problem. That one is called the product property of logarithms. And that is, if we have a multiplication problem, we can change it to addition. So the product property of logarithms. If you're multiplying 2 things together, you can change it to an addition problem. If you have an addition problem, you can change it to a multiplication problem. And here's an example. Okay? So we have the product property, which is kind of like the product property of exponents. As long as the bases are the same and you're multiplying, you can add exponents. So as long as the bases are the same and it's a multiplication problem, you can add them. We're going to go back, but I just wanted to show you. The next rule is the quotient rule. And the quotient rule says that if you have a division problem, you can change it to the subtraction. And then here's an example right here. Or if you have a subtraction problem and you need to, you can change it to a division problem. And right now it might sound like mumble jumble, but once we do a problem, you'll actually see what I mean. And then the last property we have, and the reason I bring this up to you is because this is the one that we use this one a lot, is the power property. And that is when you have an exponent, and we did one of these already in the do now, the practice problems. If you have a power, you can put the power in front, and you take the power and you put it in front of logarithm. The reason I bring that up is because we usually work backwards. Usually there's going to be a number in front of log and we're going to use it as an exponent. But we do use this power property of logarithms a lot. So again, product, quotient, power. Product is where you change it to an addition problem, an addition to a multiplication. Quotient, a division problem to a subtraction problem, or vice versa, subtraction to a division. And then power is where you're going to take that power and you're either going to put it in front of the word log or you're actually going to make it an exponent. So we're going to go back to example 1 so I can show you. And we're actually going to apply the power rule right now. So it says, use log base of 4 of 2 equaling 0.5 to approximate the value of log 4, 32. So that's the one that we're going to look at. So again, you guys, the thing that you need to know about this is they're either going to give us something or it's something that we know. So let's start with log base 4 of 32. Now, look at what they gave us. They gave us log base 4 of 2. So log base 4 can't change. But can I change 32 so that it's a 2? Can I rewrite it so that 32 is a 2? Yeah. So how many 2's do I need? 5. Okay, so we're going to rewrite this. So instead of writing 32, I just wrote 2 to the 5th. Now, what I can do is use the power rule. The power rule states when there's an exponent here, that is going to go in front of log. So I'm going to have 5 log base of 4 of 2. Now, look, you guys. They gave me something, right? I know. What is the log of 4 base of 2? What did they say? 0.5. So this becomes 5. Instead of writing log base 4 of 2, I'm going to write 0.5. So I'm replacing this with what they gave me. So again, you guys, it's either going to be replacing with something you know or something they gave you. And what is 5 times 0.5?
5.
And that's your answer. Now what I want to do for you guys is I want to do a problem that you guys did on the bell work today. Log base 5 of 5 to the 12th. So I want to show you the difference between something they gave us and something we know. Okay, so they want us to evaluate this or to approximate this. Okay, so you notice that there's an exponent. So we're going to rewrite this. So 12 comes in front of log base 5 of 5. Now, what do we know? We know something, right? What do we know about log base 5 of 5? It equals 1. So this becomes 12 times 1, which is 12. So something we know, something they gave us. Because we know that the log of base 5 to 5 of 5 is 1. Okay. We're going to skip the sound. We'll do that one tomorrow. Let's go to number 3. It's on the back of your notes. Okay. Given log 3 of 7 is approximately 1.7712, approximate the value of log 3 of 49. So we have log 3 of 49. I need it to be a 7. So is there a way that I can rewrite 49 so that there's a 7 instead of a 49?
7 squared.
So I'm going to rewrite this as log 3, 7 squared. So I'm replacing 49 with 7 squared, which is good because that's what I have. Now, what do I do with this 2? Put it in the front. Okay, so here's my question. You either know it or they gave it to you. So do you know what log base 3 of 7 is? Do you know it?
No.
Did they give you something? What did they give you? So they gave you the replacement. So instead of writing log base 3 of 7, you're going to replace it with 1.7712. And what is your final answer?
3.5424, approximately.
Yep. Okay. Good so far? Now, what we're going to do is we're going to have an equation. So we're going to we might use the product rule and the quotient rule. We might use the product rule and the power rule. So let's see what we're going to do. So we're going to solve the next one. So we're going to do this one on the other side. You don't have to flip it, but it's number 1. Okay. Now notice they're not giving you anything. So that means it's going to be something you know. Okay, so on this side, see how it's an equation, it's not by itself. So that means that we're going to have them identical. And what I mean by that is it needs to be log of base 7 and then something. Log of base 7, because we can't solve a logarithmic equation unless the logs and everything look identical. So how can I rewrite 2 times log of base 7 to the x? What can I do with this 2?
Make it x's exponent.
Yep, so we're going to rewrite it as log of base 7 x squared. So now we're making it look like section 7.2 equals, well, now we're going to go to that product rule. See how we're adding? Well, you guys, you can't solve and you can't add logarithms. It's not like square roots where you can say, if I have the square root of 5 plus the square root of 5, I have 2 of them. So I can rewrite this problem as log base 7 of 27 times 3. So if it's an addition problem, you can rewrite it as a multiplication problem, which I just did. Now, if I gave you this problem, now could we solve it? How would you solve it? Log base 7 and log base 7 are the same, so we would just set it x squared equal to 27 times 3. Well, what is 27 times 3? 81. So again, I just used my product rule that says if you have an addition problem, the bases are the same, you can change it to a multiplication. Now, how do I solve x squared equals 81? We're going to take the square root of x squared, and we're going to take the square root of 81. And what is the square root of x squared? And what is the square root of 81? And then we should always check it. And you know you can do it because it's positive, it's not negative, so this works. And it equals 81, so that is my final answer. I have one more that I want to do before the bell rings. I know we're getting close, but please don't pack up yet, okay? Okay. Log 6x plus log 6 of x plus 5. Okay, so that's an addition problem. So what do we do with those? When it's an addition problem, how do we rewrite it? Log 6 of x times x plus 5. Remember, you can only really have one logarithm on each side. Okay, so what is my base? Now I only have one logarithm, so I'm going back to what is my base? 6. What is my exponent? 2 is my exponent, and what does it equal? When there's one logarithm on one side, you go back to that exponential function. What is my base? What is my exponent? What does it equal? Well, what is 6 squared, you guys?
36.
What is x times x? What is x times 5? Now remember, you leave x squared. You leave 5x. I'm going to move the 36. So when I move the 36, it becomes, now we have to factor this. So again, you guys, I multiplied it. I have to factor it. What are two numbers when you multiply, you get negative 36. When you add them, you get positive 5.
Positive 9, negative 4.
Let's make sure. Positive 9 times negative 4 is negative 36. 9 minus 4 is positive 5. Now when I solve it, what do I get? Now, you can't have the logarithm of a negative, and there we go.